Welcome to Algebra 2, Unit 8, Section 5, Angles of Elevation and Depression. Anyway, the angle is sad because he's an angle of depression. Okay, so an angle of elevation is the angle formed by a horizontal line and an observer's line of sight to an object above the horizontal line. An angle of depression is the angle formed by a horizontal line and an observer's line of sight to an object below the horizontal line. And the best way to observe this is with this diagram. So here we see in this diagram we have a picture of a jet and a battleship. And you'll see here that we have a horizontal line that the jet line of sight is on. And if the pilot looks down at the ship, he's looking down at this angle right here. If there's an observer on the deck of the battleship, and he looks up at a 20-degree angle and he sees the airplane, the jet, then he would have a 20-degree angle of elevation. Now, the thing that's interesting about this is that this angle here, this 20-degree angle here, is the same as this angle of depression. Both of these angles are congruent, okay? So the one thing we can do with this, we can actually solve this using some trig functions. So this is down here a right angle, right? So this is the right angle on this triangle, okay? So on a pilot's front display, he can actually, with the technology now, when he turns his helmet and looks down, it'll tell him what the angle of depression is. So he can actually go ahead here and calculate this value of how far he is away from this ship. Okay. Now this is the hypotenuse, right? It's opposite the right angle. So we would have to use tangent, right, because we don't have a hypotenuse, we can't use sine or cosine. So we would say the tangent of 20 is equal to the opposite, 10,000, divided by the adjacent, which is x, and we can actually switch those out and get x by itself by just switching it with tangent of 20. So 10,000 divided by the tangent of 20 would be x, and we're going to take 10,000 divided by tangent of 20. And we end up with 27,474, right? So x is equal to 27,474. And if we wanted to get technical and say, well, how many miles is that? Well, we would just divide that by 5,280 feet in a mile, and we come up with 5.2 miles. So it's approximately 5.2 miles. Okay.
Super fun math fact.
Well, we're traveling back in time here, and we're going to talk about Eratosthenes, who lived from 276 to 197 BC, and he was a mathematician and an astronomer who was born in Cyrene, which is now located in modern Libya. And he used the angle of the elevation of the sun at noon in the cities of Alexandria and Syene, which is now in Egypt, both of those, to measure the circumference of the Earth. So this guy was able to, approximately 2,200 years ago, figure out how large the Earth was, which is pretty astounding. Okay, angles of elevation or depression to two different objects can be used to estimate the distances between those objects, and the angles from two different positions of observation to the same object can be used to estimate the object's height. Okay, so Leia wants to see a castle in an amusement park, and she sights the top of the castle at an angle elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leia is 5.5 feet tall, how far is she from the castle to the nearest foot? Well, you can see here in this drawing that we've kind of gotten this area right here that shows a gap. Right? We have this gap here because this goes to the ground. 190 feet goes to the ground. So this gap here is 5.5 feet. So the question is, what's this distance? Well, we are going to subtract that out, right? Because if this distance in here is 5.5 feet, then this would have to be the remainder, which would be 184.5 feet. Now we're going to look at our situation and we say, okay, we can't, this is the hypotenuse right here. We don't have that value. We don't know what that is. But we do have this value right here, and we have our variable x. And we have this angle development. So the only function we can use is the tangent function. So the tangent of 38 is going to equal the opposite, which is 184.5 over adjacent, which is x. So we're going to use our little trick where we take this and we, oh, hold on, we're not using our little trick here. We're going to take our little trick and we're going to switch, and then if x is equal to 184.5 over, oh gosh, the tangent of 38. So now we pull out our calculator and we go ahead and we divide 184.5 divided by tangent 38. Hit enter. We have 236.1, so she's approximately 236 feet from the base of the castle. Next, a search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to this other person is 42 degrees and the helicopter is 18 feet above the water, what is the horizontal distance from the rescuers to this person to the nearest foot? So it's hard to see this person here, but I'm going to highlight them, right? And they're screaming help, and this is X, and this is 42 degrees, right? And here's our triangle. We can sort of see that there. And one of the things that most people are not aware of, or could be aware of, or but we'll have a little fun here, is there's a large shark in the water waiting to enjoy a morsel. Okay, so we've got to work fast here. So let's go and do some math so we can save this person from the shark. So the tangent of 42 42. Oh, that shark's circling. We better move quicker. Tangent of 42 is equal to opposite 18 over adjacent x. So we're going to switch this. X is equal to 18 over the tangent of 42. This is where our calculator becomes very handy. 18 divided by the tangent of 42. And that's 19.99. So this helicopter needs to get the person on the rope up into the helicopter and then slide over another 20 feet and grab said individual out, saving himself from becoming shark food. That's dark humor right there. Okay. Now these other two problems we had a picture. In this problem we have no picture. So one of the things that helps to do with these type of problems is you sketch a drawing. So we're going to do that right here and now. So I'm going to draw the sun. And in my best Bob Ross style, he's a happy sun. And next is going to be my tree. So I need to draw a tree. So and this is a stately pine tree who lives right here. Right? And you know what I'm going to need to do? He's a little too tall for my drawing here. Okay, let's go this way with him. There we go. Okay. And so here comes the sun's rays, right? And a shadow is cast. So we've got a shadow here. And there's our picture. Okay. So the angle of elevation is 58 degrees. And this distance here is 20 meters long. And I'm going to say this is not drawn to scale. Okay? So we're going to now set up our function. We don't know the height of the tree, so that's x. So again, we're going to use tangent. I think you might notice a pattern. We use tangent mostly with angles of elevation and angles of depression. So tangent of 58 equals the opposite, which is x over 20. So this one we don't have to do any switching. We just have to multiply each side by 20. So 20 times the tangent of 58 is equal to x. So now we can just plug that in. 20 tangent 58. And I've got 32 meters. So the tree is 32 meters, right? Which when we convert that to feet, that's approximately 105 feet. I know because I've done the problem a few times. All right, let's move on here. Two observers on the ground are looking up at the top of the same tree from two different points on the horizontal ground. First observer, who's 83 feet away from the base of the tree, looks up at an angle of elevation of 58. Second observer is standing only 46 feet away from the base of the tree. So how tall is the tree to the nearest foot? Well, here we go. We got to do another drawing. So I'm going to make my tree. This tree's going to look like this one here. And here's our trunk. And here's observer number 1. He's just standing out here in the middle of nowhere. And he's looking up at this tree, and we're ignoring, however, the height. All right, so he's 83 feet away. And he's looking at a 58-degree angle. Now the other observer is only 46 feet away. And they are looking up at this angle here. And we're going to call that theta because that is the variable for an angle. So first thing we're going to do is find the height of the tree, x. So tangent of 58 is equal to opposite x over adjacent 83. So we're going to multiply each side again by 83. This is just like our other problem. So 83 times the tangent of 58 is equal to x. Great time now to pull out our calculator and plug in 83 tangent 58. So the height of our tree, x, right? The height of our tree is 132.82. So we're going to say 133, right? So x is 133. Now the question is, okay, what's the angle of elevation for our observer? So okay, so the angle we know is we don't have the hypotenuse, so we're going to use tangent. So the tangent of theta is equal to the opposite, 133, over the adjacent, which is 46. So to find the angle, we have to switch that out. So we switch those two, but we put the inverse, tangent negative 1 of 133 over 46 is equal to theta. So we're going to use our calculator here, and we're going to plug that in. Second tangent, right, gives us the inverse, 133 divided by 46 equals theta. That comes out to 70.921. So theta is equal to 71 degrees. So that ends our lesson on angles of elevation and angles of depression. Have a great day. Peace.